How do you store and version AI models in Cloud MLOps environments? Think of model versioning like leaving a string of lanterns behind you during a night hike. Each version lights the exact path you took, so you can always step back safely. Every model snapshot stores its data, metrics, code state, and training conditions, giving you a complete map of how it evolved. This matters because drift creeps in quietly. Fraud tactics shift, user preferences change, new slang appears. Versioning with cloud storage and a clean registry gives you predictable, reversible upgrades, like choosing which save point to load in a game. Interviewers love hearing, versioning ensures reproducibility and gives me instant rollback control. They'll often follow with, how do you choose a rollback point? A confident reply is, by comparing lineage, metrics, and drift indicators across versions. Don't worry if this feels abstract. It becomes intuitive once you see how versioning protects your system from silent failures. Reliability starts with knowing exactly where your model has been. Core storage and versioning approach. Imagine the workflow moving through 3 rooms. The basement is cloud storage, where raw model files sit like sealed equipment, heavy, durable, and out of the way. The notebook room is powered by tools like MLflow or DVC, capturing hyperparameters and metrics the way a scientist annotates every experiment. And the shipping room is the container registry, packaging the model with its exact dependencies so it behaves the same everywhere, even when Python versions disagree or GPUs differ. This 3-room flow is why large companies avoid works on my laptop disasters. In interviews, a crisp line is, I separate artifact storage, experiment lineage, and container packaging to guarantee reproducible deployments. If pressed with, why not use DIT for everything? Calmly explain that models are large, binary, and update too frequently. Once this mental model clicks, the whole pipeline feels clean, predictable, and easy to operate. Model lifecycle pipeline. The lifecycle feels like a smooth, looping choreography. Data enters like raw ingredients, each version tagged for traceability. Training becomes the kitchen, capturing the recipe, metrics, hyperparameters, and lineage. The registry is your pantry. Every trained model on a clearly labeled shelf. Deployment serves the dish, and monitoring constantly tastes it, noticing when flavor drifts, just like soup becoming bland after hours on the stove. Teams running recommendation engines or demand forecasts rely on this loop daily because user behavior shifts nonstop. Interviewers often ask, how do you compare 2 model versions? A strong answer is, I check lineage, dataset versions, and evaluation metrics in the registry. If the loop feels long, breathe. It becomes instinctive. Once the rhythm settles in, the pipeline feels less like engineering and more like a steady, repeatable craft. Common interview follow-ups. Let's take a gentle pause here, because this section tests your depth. Drift is like your GPS slowly sliding off the road. You don't notice it until predictions feel wrong. Fraud models face this when attackers adapt. Speech models feel it when new accents emerge. Rollbacks are your emergency lever, letting you revert instantly thanks to stored versions. Reproducibility comes from versioning everything, data, code, settings, so the model behaves identically across machines. Compression matters when latency budgets are tight, shrinking models with quantization or distillation so they run fast without losing personality. And huge models often need chunked uploads or sharded storage. Interviewers love asking, what's your earliest drift signal? A grounded reply is, Shifts in feature and output distributions over time. Over time, these patterns feel natural. Stability becomes the quiet signature of a mature engineer. Best practices checklist. These practices become your guardrails. Semantic versioning labels each model like a chapter title. 1.3 immediately signals change. Size. Automation reduces manual mistakes and brings calm repeatability. Access control protects your registry like a locked cabinet in a lab. Documentation, especially model cards, becomes each model's biography. What it learned, where it should be used, what risks it carries. Older versions often move to cold storage, like placing important papers in a climate-controlled vault. Security wraps everything with encryption at rest and in transit. Interviewers may ask, how do you keep automation from becoming risky? A sharp answer is, I automate the pipeline, but enforce strict registry approval gates. Don't worry if the checklist feels heavy. It becomes muscle memory. With strong habits, your models stay reliable, explainable, and ready for future work. Great job learning today. If this helped you feel clearer or more confident for your AI or ML interviews, tap like so more learners can find you. If you want simple guidance for every interview topic, subscribe so you never miss the next lesson. You can share your questions in the comments. I read them, and they help me choose what to teach next. And if you know someone preparing for interviews, feel free to share this with them. Keep going. You're improving with every step. I'm here to help you grow.